All right, let's just jump right in. Every single time you go online, you're basically stepping into this huge invisible world. So today, we're not just going to talk about cybersecurity and networking. No, we're going to become digital detectives. We're going to learn how to actually see what's happening all around us, right under our noses.
So let me start by asking you something. Right this second, what is your computer or your phone or even your smart TV? What are they actually doing? What conversations are they having in the background? It's kind of a mystery, right?
Because, while you're just browsing, a lot can be going on. Things like data breaches are a constant threat.
And so is financial fraud. Attackers are always looking for those little vulnerabilities that we don't even know exist. The stakes, they're incredibly high.
And here's the thing. All of our devices, they are constantly talking. They're sending signals, opening connections, chatting back and forth. So the key to protecting everything is to learn how to listen in, to understand their language, and that is exactly what we're going to do today.
So, welcome to the invisible digital world. Before we can start our investigation, we really need to get the lay of the land and figure out what it is we're trying to protect in the first place.
At its very core, cybersecurity is really just the practice of protecting our digital stuff. Think of it like the locks on your doors, the alarm system for your house, and the security guards for your most valuable information. It's our first line of defense.
Any good detective needs two things: a map of the territory and an address book of all the important locations. Well, for us, our map is understanding how the internet works, and that address book, that's what we call IP addresses.
So how does a website actually get to your screen? It's basically a four-step dance. First, your computer asks something called a DNS server, just think of it as the internet's giant phone book, for a website's address. The DNS server looks it up and replies with a unique IP address. Then your computer uses that address to connect directly to the server, and boom, the server sends the website right back to you.
Simple as that. That IP address we just talked about, it's literally like a street address, but for a device. Every single thing on a network has one. You have a public IP, which is how the rest of the internet sees you, and then you have private IPs for all the devices inside your own home network, like your laptop talking to your printer.
Okay, so let's stick with that analogy. If the IP address is the building's street address, then network ports are all the different doors into that building. And each door is numbered and has a specific purpose. For instance, port 80 is kind of like the main unlocked front door for regular web traffic, while port 443 is the super secure encrypted door for things like online banking.
So, how does the data actually travel through those doors?
Well, there are two main ways. Think of TCP like sending certified mail. It makes a connection, makes sure every single piece arrives, and puts it all in the right order. Super reliable. Then you've got UDP, which is more like sending a postcard. It's way faster, but there's no guarantee it'll get there. That's why it's great for stuff like video streaming. Now, for a defender, knowing this difference is absolutely crucial, because that no guarantee part of UDP can sometimes be a blind spot, making it a bit harder to track, and a place attackers love to exploit.
Okay, so we've got our map, we understand the basics. Now it's time to get our hands on our first real detective tools. And for that, we're heading into the Linux terminal.
Now, don't let the terminal scare you. Seriously, it's just a way to talk to your computer directly using text commands. You'll find it in Linux, and you can even get it on Windows now with something called the Windows subsystem for Linux. For our purposes, this is the ultimate detective kit. It's our magnifying glass and our evidence notebook all rolled into one.
Our very first tool is super simple, but so powerful. IPA.
So what does it do? Just like that, it tells you your own IP address. In our little detective story, this is how you find yourself on the map. It's the big red "You are here" marker.
Next up, one of the most classic fundamental commands in all of networking, ping.
Ping is basically like walking up to a house and knocking on the door. You send a tiny little signal, the ping, to a server, in this case Google's public server at 8.8.8.8, and you just wait for it to answer back with a pong. It's the fastest way to see if a machine is online and listening.
And for our last tool today, we've got a real powerhouse, especially for doing a bit of reconnaissance, netstat.
Okay, this command is like having a master key. It literally shows you all the open doors, remember, the listening ports, on your own system. This tells you exactly what services are running and just waiting for a connection. It's like getting a full blueprint of the building's entry points.
So we have our tools. We know how to look around. But finding the clues, that's only half the job. The real point is to use what we find to protect a system. It's time to start thinking like a defender.
Let's try a little scenario.
Imagine you use your tools and find a server out there with 3 ports open: port 22, port 80, and port 3306. As a detective, what story do these clues start to tell you?
Okay, here's how an investigator would break it down. Clue number 1. Port 22 is for something called SSH. That means someone can remotely log in and control this thing. Clue number 2. Port 80 is for HTTP. That tells us it's hosting a website. And clue number 3, port 3306 is for MySQL, which means it's running a database, probably for that website. See? Just 3 little clues, and we've already figured out what this server does.
So, if you're the one defending this server, what's your move? First, you get a firewall up to control who can even knock on those doors. Then you start asking questions like, does that database really need to be open to the entire internet? Probably not. So, you close that port. You start monitoring the traffic for anything weird, and you make absolutely sure everything is updated. This is how investigation turns into action. It's all about making yourself a smaller target, giving the bad guys as few doors as possible to even try.
Whew, we have covered a lot of ground today. We've mapped the internet, we've picked up our first detective tools, and we've seen that with just a few simple commands, you can start to understand those invisible conversations happening all the time. So I'll leave you with this one question. You now have the tools to look. What will you discover?